All right, guys. So let's start our work with the practice about Lewis dot diagram. We're going to figure out potassium first. So potassium, the first step is figure out the symbol. So you can figure out the symbol of potassium by looking at the periodic table. Potassium is a metal, so I'm going to look on this left side. And here I can see potassium. It's in the group 1. That means it has 1 valence electrons. All the elements in the first group has 1 valence electrons in their outermost shell. Okay, and potassium is one of them. So I'm just going to say K for the potassium. That was also the question yesterday in the prime time, which most of you guys failed the trick. So potassium is actually different than others when you name the symbol. So anyway, K, and has 1 valence electron, so I'm going to put that here. Actually, you can put this dot on the side, on the bottom, wherever it's convenient when you are making the bond. It's not a must thing to start on the top, but just to make sure you're putting the correct amount of dot, okay? And you're doing this one at a time. And that's it. That's all about potassium's electron dot diagram. So how about bromine? Bromine is bromine. It looks like a nonmetal. It sounds like a nonmetal. So somewhere here on the right side, right there, bromine, the 35 atomic number. But we don't care about the atomic number. We care about the group number. What group bromine has? Bromine is in group 17. So if it's group 17, it has 7 valence electrons. Remember, 3 through 12, we don't use this rule for the transition elements. We can use this rule for only 1, 2, 13, 14, 15, and so on, okay? All right, so bromine has Br as a symbol. Make sure the second letter is small case. And then group 7, that means it has 7 valence electrons in its outer shell, okay? It's like 2 in the first, 8 in the second, another 8 in the third, another 8 in the 18 in the third, in the fourth. And then, so the last shell has 7, that, which is called valence electrons, right? So it has 7, 1, 2, 3, 4. Well, this is not what we are doing, right? This is not what we're doing. I made the wrong representation. 1 at a time. 2, 3, 4, 5, 6. I forgot what numbers we got. 7, right? Okay. 7. So this can change. Like you can put the dots like this. And then you can just put the dot over here on this right side. Or that one dot can just come to the top and others can like switch their places. As long as you put the correct amount of dot, that's fine. Now let's do the argon. Well, argon is in the group 18. Argon is in the group 18. So you're asking yourself, why she's doing argon? She's one of, it's one of the noble gases. It's not making any bond. Noble gases doesn't need to make bond because, I wanted to show this to you because it has a fully filled outermost shell, the most stable element, the most stable element here, right? Stable already from the birth. So this is not going to make any bond. But I want to show you the octet. So the octet, argon is in the octet situation. Remember the octet? The octet rule is saying that all elements want to reach to the octet situation, the most stable situation, just like helium, neon, argon, noble gases in group 18. So group 18 has 8 fully filled outer shell. Okay. Anyway, so let's get to the bonding. So today we are going to learn actually how those elements make bonding. Now that we know how to draw electron dot diagram, we can know how many bonds each element will do with others. Let's get to it. All right, so in the following 10 minutes, we're going to learn and practice with how to show bonding between two elements, especially specifically metals and non-metals. So we're going to be making ionic bonding. You don't have to learn the covalent bonding, like how covalent bond happens. You're going to learn in the chemistry. But now let's get to the steps. So we have a couple steps to show you. So the first one is you're going to draw the electron dot structure, the dot diagram of that element, of that both elements, okay? Of those both elements. And then you are going to transfer the electron using an arrow. You're going to transfer the electron from metal to non-metal. Using the arrow, you're going to show how it's going to transfer and where it's going to transfer, okay? And then if both elements are stable, we're just going to stop there, which means if both elements reach out either 8 or has nothing around, that means it is stable and we got to stop the work. But if there is still extra leftovers or there's still empty holes, like empty spaces around the element, which is not 8, then we're going to keep adding one of the metals or one of the non-metals, okay? And then lastly, as we add elements, we're going to continue transferring until all atoms are stable. We're going to write the chemical formula using the subscripts to show how many of each element you used to make both elements stable. All right, so let's do the first example. What compound will form between sodium and chlorine? So what is sodium? Look in the periodic table right here, group 1. Sodium is in group 1 and it's Na. So we put the symbol and we just put one dot because it's group 1. This is how you just become ready for making the bond. And then what is the other one? Chlorine is the other one. And chlorine is a nonmetal and it's close to the end. It's chlorine here, right? It's in group 17. That means it has 7 electrons. 1, 2, 3, 4, 5, 6, 7. We have an empty space here, empty hole. So we're going to fill this hole because chlorine needs 1 to be 8, to become 8. So it can become stable, right? And sodium has 1 to get, it needs to get rid of this 1 because it's a metal. You know, remember metals gives their electrons, non-metals gain the electrons from others. So what's going to happen is that electron is going to go to the chlorine and they're going to make this formula, sodium chlorine, okay? How do we name ionic bonds? So normally we use sodium and chlorine, right? Chlorine ending with Ne. But after they combine, they make the chemical bonding, the name has changed slightly, which is in the end of chloride. So sodium chloride ending with D, this is the name change happened after the chemical bonding. So you will see this ide ending with ide syllabus. You will see this in almost all ionic bonds, okay? All right, let's get to the second example. What compound will form between lithium and fluorine? So lithium, we put the lithium symbol there. Lithium is in the group 1 here, as you can see. And it has, because it is group 1, it has 1 dot. I just put 1 dot. We're going to put 1 dot there. Okay. Here. And fluorine is in group 17, so I'm going to put 7. 1, 2, 3, 4. Mrs. Maidan, you keep doing this. Don't do that. Don't forget the rule, Mrs. Maidan. Follow the rules. 1, 2, 3, 4, 5, 6, 7. Sometimes knowing too much things can make you do wrong. Anyway, what's going to happen now? Fluorine has an empty space to become stable, to become 8, right? We're trying to be 8 here. but we have 7. So we need one more. We need one more, right? So what are we going to do? Lithium is going to transfer, which makes it ionic bond, right? It's going to transfer its only single electron to the fluorine. And this is how you're going to show bonding, okay? All right. Now, just because we use only one lithium and one fluorine to make both stable, as you can see, both are stable. Lithium has nothing now. Lithium has nothing now. And fluorine has now 8. 1, 2, 3, 4, 5, 6, 7, 8. That 8 is coming from the lithium. And lithium has nothing around, which is also called stable. Metals, usually metals will not have something around after they transfer because they already have a fully filled shell in their previous shell after they lost the outer side, okay? So now the chemical formula is lithium fluoride, ending with D, okay? So this is fluorine. It's ending with INE, okay? Now, after that, lithium fluoride. It becomes lithium fluoride, okay? All right, let's move on to the next example. All right, what compound will form between aluminum and chlorine? This is going to be a little different than others, a little more task to do, a little more work to do. First, we're going to draw the electron dot structures of the elements. Aluminum is right here, so it's group 13, and it has 3 dots. Group 13 has 3 valence electrons, so 3 dots around. And chlorine has 7, so we're going to put 7. And then what's going to happen is we're going to transfer one of those dots from aluminum to chlorine because chlorine needs just 1. However, what's going to happen to the leftovers in aluminum? They have to be bonded too, but there's there's nothing else here to make them bond. So we are going to add chlorine, another chlorine, and this one of those, the second one is going to go to that chlorine. Since we have 1 left over, we're going to add the same atom here, the same chlorine, and the last one is going to be transferred to the last chlorine. Well, since we are trying to make compound between aluminum and chlorine, like nothing else, we kept using the same chlorine, right? Because this is what we want to do. Just because of that, just because to help aluminum to get rid of all those 3, we used 3 chlorines. So in this case, aluminum made 3 bonds in total, like 1, 2, 3. However, the chlorine just make 1 bond, right? This chlorine make 1 bond. This chlorine makes 1 bond. This chlorine makes 1 bond. So our chemical formula, since we use 3 chlorines to make each type of element stable, our chemical formula will be aluminum chloride. So, okay? Aluminum and chloride. I'm sorry, I made a mistake here. Aluminum and chlorine combine together to make aluminum chloride. Okay? All right. Now it's your turn. Answer the puzzle question. What kind of bond will happen between potassium and chlorine? Choose the best choices. After you choose the best choices, you're going to come back and see the correct answer. All right, so this is the correct answer for potassium. Chlorine needs 1, potassium needs to get to the 1, so that 1 is going to go there. Since we use only 1 K and 1 Cl, the formula is going to be KCl. Potassium chloride turns into potassium chloride. How about magnesium and fluorine? Since magnesium has 2 to get rid of, fluorine has only 1 to get rid of, we use 2 fluorine to help magnesium to get rid of 2 dots. So we add 1 more fluorine here, and each goes to fluorine to also make the fluorine stable. And the chemical formula is magnesium fluorine with 2F, okay? Because we needed to use 2F. to help magnesium to transfer those two dots. And then how about the third one, aluminum and nitrogen? So aluminum needs 3 not to get to the 3, to give 3, and nitrogen needs to gain 3 from aluminum. I think they made a pretty good couple to make each other stable. So we just needed to use 1 from each to make this bond. So aluminum, nitrogen. Aluminum and nitrogen. Now this turned out to be, so the name of this compound is aluminum nitride. As you can see, it ending with "ide" again. So let me write this down for you. So aluminum and nitrogen made a compound, and now their name is aluminum nitride. Nitride. So this IDE is still the same. So this IDE is gonna, this is how they end with IDE, because this is an ionic bond, okay? Again, most of the ionic compounds are going to name as this with an IDE ending, okay? Magnesium and phosphorus. This is the most challenging question. Let's see who's going to get the correct answer. Are you guys drawing these on a piece of paper? Make sure you do so. All right, so magnesium is in the group 2, so it has 2 dots. Phosphorus is in 1, 2, 3, 4, 5, is in group 15, so it has 5 valence electrons. What's going to happen? One is 2, one is 5. Like phosphorus needs 3. So I have to have 3 electrons from others, from magnesium. But magnesium has only 2. So one of those goes there, other one will go there, but phosphorus still needs 1. So another magnesium is going to come to help. And those two, one of those dots will go fill in this dot, fill in this empty space in phosphorus. But guess what? Phosphorus is now stable, but now magnesium, my second magnesium, is not stable because it has 1 left over. Where is this going to go? So I'm going to add 1 phosphorus here. Now start over. This will go there. Now phosphorus needs 2 more. 1 here, 1 here. Who's going to provide that? Of course, another magnesium will come to help. And this time, finally, magnesium, 2 of those dots are going to go there. And everybody is happy now. Are you guys happy too? Because this is the end of the video. Hopefully, you guys are going to answer the questions correctly. This is going to be counted as quiz. So do a good job. If you want to reset this, I can reset it for you to do a better job, to do a better score. Okay? Bye-bye. Have a great winter break. So that I exposed you to this before the winter break, but I had to, and you had to learn this before going to the winter break so that we can start fresh with the physics topics next year. Happy 2021.